So, what is additive manufacturing? Additive manufacturing is the industrial production name for 3D printing. It can produce almost any shape of three-dimensional solid 3D printing, and it prints objects by stacking and accumulating layer by layer. It is widely used because of it prints manufacturing components with virtually no geometric limitations or tools. These are the additive manufacturing techniques, and throughout this video, we'll talk about three techniques, which is wet photopolymerization, powder bed fusion, and binder jetting. This is how additive manufacturing works, and it might be difficult to understand by just reading the words. The next slide will show the diagrams of additive manufacturing works. An engineer designs the object using computer-aided design or CAD software. The 3D design file is then sliced into thin layers and uploaded to an additive manufacturing machine. The manufacturing process begins with an extremely thin layer of powder is spread across the platform. A heat source such as laser or electron beam is then melted the first layer of the 3D design. Then the platform is lowered and another metal powder is spread across the platform. This is repeated until the part is produced. Lastly, the metallic powder is removed and the physical object is revealed then. It is shown at the fourth diagram. The left diagram shows the schematic diagram of the 3D printing, and as I said, the nozzle head will emit some kind of laser and electron beams to deposit the metal powder, and the right diagram shows the direction of the laser beam scanning. Additive manufacturing provides a lot of advantages, and I will state three major advantages. The first advantage of additive manufacturing is it provides less production costs. It will eliminate the storage cost mass reproduction and gives a lower unit cost by entering into market. In comparison, it has lower tooling costs, which allows smaller, low-volume manufacturers to enter into the marketplace. Manufacturer would not take too much decision to increase the unit price. So it already win big in business field. Next, it will gives full control over designs. Usually, when we change our designs to accommodate their processes or materials, this may cause losing control over design and may face a risk that our prototype is not fully reflect the design intent. Thence, additive manufacturing allows manufacturer have more timeline control and process visibility, allowing manufacturer to full control over the design. So complex shapes and geometries is also not a big problem if using 3D printing. 1. It reduces waste production. In many cases, business is won or lost based on the speed to market, and sometimes the success of the entire organization is at stake. It reduces the production lead time, and it won't have to wait until the market research or wait the tooling to be completed. Using additive manufacturing also gives disadvantages to manufacturer or engineer. First is it requires post-processing. The surface finish and dimensional accuracy may be lower quality than other manufacturing method since it is deposited layer by layer. Additive manufacturing also has a critical disadvantages, which is slow build rates. The speed of the additive manufacturing is 1 to 5 cubic inches per hour. The layered parts surfaces, which are curved or tilted in respect to the building platform, will face a strange stepping effect. This effect causing it takes more time to complete the processes. And the last one is additive manufacturing has limited component size or small build volume. Metal parts are limited. The printing only able to print 1 cubic foot, while larger machines are actually available, but the cost also is higher. Okay, let us move on to the limitations of additive manufacturing. Additive manufacturing also has limitations. The first one is size limitation. It unable to print architectural structures. And second, the raw material limitations. The items are made of single material only, and some biomaterials such as bioink, which are still immature. And the third one is negative media effect. Additive manufacturing is just arrived to experience part of the public which cannot handle by most of the staff of people. So how the raw material limitation is then resolved. Until today, we have single nozzle design and multi-nozzle design, which is originate with multi-material 3D printing that prints objects with different color or with different material properties. It can changes to material up to 8 different materials. This is the first multi-material 3D printer that released in 2006, and it is one of the first two open source DIY 3D printers in the world. Changing rapidly and technology thus improving too. General 3D printer which only able to print up to 1 cubic meter, and this is the biggest 3D printer so far, and it shows that it may resolve the size limitation. Continue with the application of additive manufacturing. Before we enter the application, I would like to introduce the techniques of additive manufacturing to easier explain them. The first is wet photopolymerization, and the process is done by solidifying layers of liquid resin in the shape of a 3D object by using radiation, usually ultraviolet lights. Dental applications product such as Invisalign braces with wet polymerization method, which is one of the additive manufacturing method. The next additive manufacturing method is powder bed fusion. The process is done by layers of powdered material selectively melted by a focused energy source, usually is laser or electron beam. And form and function testing is its application. In the first one, skull printing can be done to accidents patient which can really fit to them by getting the information from the actual scan of the patient and developing geometry for transporting to the body. The next application is done for the binder jetting. The process is printing begins with a single layer of powder being deposited into the build platform. The print heads then swept over the powder, selectively jetting droplets of the binder agent. Limitation is non-engineering material composite and some small part with significant shrinkage. This is the schematic diagram of binder jetting for easier understanding then. By printing the core rather than making a pattern. In low volume production, this process is usually used because of having high level of success by printing the sand and casting the finished metal parts. Patterns may also be printed. Those are not cost effective and did not jumping many processes. And the left diagram shows the part made through metal binder jetting, and the right diagram shows the part made through sand binder jetting. Thank you.